Good evening, everyone, and welcome to this workshop on the basics of Kotlin. We will check out what Kotlin is and what it has to offer us. But first, before I start, I would like to give a big thank you to Yannick for providing a lot of material for this presentation, and also for his talk last year, which got me hooked on Kotlin. So without further ado, when we look at the new language, the first thing you most likely encounter is a hello world. So here we go. For me, this is kind of tricky because I don't have a preview on my screen, so I have to look here. We run it, and it says hello world. Now, during my presentation, you might see me using this statement more often, and then it will be shorter, but it will be the same thing. So it can actually be shortened if that's your kind of thing. And it should still work. There we go. Okay, all set. Some introduction about Kotlin. First, the goal of this presentation is, what does Kotlin have to offer for me? Why should I even bother? So why should I use it? And then by the end of this talk, I hope you all are hooked and psyched to check out Kotlin at home and on your projects. So first, this is Kotlin, or Kotlin Island. It's an island off the coast of St. Petersburg in Russia, and it's actually where this language got its name from. Most developers were located in St. Petersburg, and they were looking out their window, and they thought, what should we name our language? And yeah, this is what popped up. So, okay. Now, actually, what is really Kotlin? It's not obviously an island, but it's a statically typed programming language, just like Java, where our types are known at compile time. It's developed by JetBrains, the people behind IntelliJ, which is the editor most of us use. And it compiles to JVM bytecode, just like Java and other JVM languages. And it can also compile to JavaScript. That part we won't touch this evening because it's not really for most of us, since we are more, I think, backend people. Okay, but keep in mind that it is definitely possible. And you can also use all the code you ever wrote in Java from Kotlin, which is a big plus and a big selling point. Okay, then let's go through a bit of history. It's a bit dull, I know, but should be clear that it's a fairly new language. It started somewhere in 2010 by those people in St. Petersburg who were staring out their window. And then by February 15, 2016, V1 was released. Then on Google I/O, it was also adopted as an official language for the Android, for Android. So it's that was a big boost in users and in usability. Then V1 was released in 2017. They basically incorporated a lot of feedback from developers and added new features to the language, and also relaxing some constraints that were in V1. So they really listen to the feedback from the community, which is very cool. It's also an open source project, as mentioned above. Then we had V2, and last year in October, V1.3 was released, bringing coroutines, which we also won't talk about tonight, but it's very interesting. It's basically lightweight threads. Okay. What good is a nice language if it doesn't have a lot of support and a lot of usages? Luckily for us, Kotlin has some major players on the market using it already, like Pinterest and Uber. Uber uses it for internal tooling. Gradle actually supports it since Gradle version 3. For people who use Gradle, you can use Kotlin as the language to write your build scripts. And during the exercises, you will see that I also provided our build scripts in Kotlin. You see also Pivotal, which is Spring territory, which we will talk about next week on the hands-on session and the more in-depth session. Okay, then Kotlin stands for some things. It's an object-oriented language, but it also has functions as first-class citizens, which means you can use it as an object-oriented language, like you know from Java, but it can also be used as a functional language. It's idiomatic, which means it should feel really natural to read, and it should be concise and expressive, and also very readable, because as developers we tend to read a lot more code than we actually write, so this would make sense. It's also a very safe language, because null pointers are a thing of the past in Kotlin, because it has very strict null types, safety through null types and immutability. And there's a strong focus, like I mentioned before, on interoperability with Java. So everything you wrote before in Java can be used in Kotlin, and everything you write in Kotlin can be called from Java in the same project. Kotlin also has a REPL. That was even before Java introduced REPL, so an interactive shell. How can you run it? You just type Kotlin with a C, and then the interactive shell launches. You can try stuff out and see what it does. Okay. Kotlin can also be used for scripting, which you can actually see when you look at the exercises. There will be a KTS file, which stands for Kotlin source file. For instance, if you have dostuff.kts with some statements, a print line, then you can run it by using Kotlin C-script and the name of your script, and it will execute. Okay, enough with the boring, dull stuff. Let's get into it. Syntax, finally, what does it look like? First, packages, very difficult. It's the same as in Java. You just define them at the top of your source file. No surprises there. Then we have functions. Functions are really fun in Kotlin. Yeah, that's a good way to remember it. Yeah. So we see here, it's just a simple sum function. How do you define it? It's the fun, then the name of your function, some arguments, where you pass the name and then the type with a colon in between. And the return type is also with a colon and then the return type after it. And then simply like in Java, as you know, it looks quite familiar, but this can also be made more readable. This is called method block, like we have in Java, but you can also make it an expression block, like so. And then we can get rid of the return statement. So this is much simpler. And then even now Kotlin can also infer the return type, so we don't have to specify it's an int. We can get rid of this as well. And if we execute it, it should still work. 36. So it's much more concise than Java. This is a very simple example, but you get the idea. Okay, so expression body, which is the equals sign, and then an expression, which returns your result. And that way, Kotlin can also infer the return type, and you don't need to specify it. Like this. Also, if there is no meaningful value being returned, being void from Java, we call this unit in Kotlin. It's the same thing. We don't have to specify it, you know, public static void main, it's always the void, but it actually doesn't do anything. So if you have in Kotlin unit, you can basically get rid of it and just omit it from your code, which tidies things up a bit. Then variables, there's two types of variables in Kotlin. You have immutables and mutable variables. The immutables we call values, and they are defined like val and then the name and the type, and then you assign it to something. And if you try to reassign it, the compiler will complain and it won't do anything. What do you do if you need to modify your variable at runtime? You make it a var instead of a val, and then you can reassign it or do some operation on it. This will work. But then, of course, why do you have both? Well, you prefer actually always to use immutable types, so vals over vars, because it provides a lot more safety. And also, Kotlin has something called smartcast, which we will discuss later. And there it's very important that you use immutable types, or smartcast won't work. Okay, type inference. This is the same thing as with the function, where if you would use an expression body, the equals and then something, that you don't have to provide the return type. Same thing goes for declaring variables. So here we have a value a, which is 1. Normally you should define it as being an integer, but it's omitted here because Kotlin can infer that it is a type int, so it knows it. Same goes if you define a string. Kotlin knows that it's a string and you don't have to specifically type it. So it makes your code a little bit more readable, which is nice. Okay. There's another way to initialize variables. It's called a lazy variable. What this basically does is, sometimes you have a variable, you don't know if you will use it. Let's say you have to do some I/O, you need to read a file or fetch something over the internet. You only want to do this very costly operation if it's really necessary. So it might be that you don't even use it and then you just don't want to do it. So it's being evaluated lazy. So it will print something. In this case, it should read a file or do an HTTP call and then return some value. In this case, it's all powered up. This is an expression in Kotlin here, and the last line is always returned. So this will be the value of our lazy value. Now, if you execute this, still lazy, it shouldn't be evaluated yet. Then we would see the powering up and then all powered up twice, because the powering up will only happen once because of the lazy evaluation. And that's exactly what we got. Okay, so it's only initialized when it's used. Okay, then another really cool feature in Kotlin is string interpolation. We know string concatenation from Java, but here we can actually define string templates. It works like this. You define a string, and then you can use a $sign with a variable that then gets injected or interpolated with your template. So if you run this, then you get hello Kotlin as expected, but it's really nice to read. And you can also do more complex things instead of just injecting variables by, let's say we want to also make a yell. So I define a yell, and it's hi, followed by, we want to uppercase our name to really yell it. Let's say name dot to uppercase. I made a typo here. And then if we print it, our yell should be uppercased. See, so it's still pretty readable, but it's yeah, a nice way instead of just using concatenation. Behind the scenes, it does the same thing as concatenating this. As it uses then behind the scenes a string builder, so there's no performance loss. Then we also have multi-line strings, which is a feature I really miss in Java. Like you see, this piece of text could also be a piece of HTML. So you can define it on multiple lines instead of all the +++ and new line characters concatenated. We've all seen this, we've all done this, or just move it to a separate file and then read it just to avoid this kind of thing you don't have in Java. Then if we run it, we see what we would expect because of the trim indent. If we play with this, you can see that, it works still as expected. You can also use, instead of trim indent, you can use trim margin and then provide some kind of token that would indicate the beginning of your the text that you want. Let me show you like this. For instance, we want this to be here. And if we run it now, it will trim everything until the character that we defined. So this makes it that you can arrange it even differently from what you would like to use it in. And also string interpolation also works here. So let's say we want to make this a variable and we define it at the top. And we run it, it will get injected like so. So it's a very powerful feature and very nice to work with strings. Okay, comments, same as in Java. No weird things there. Okay. Then we have if expressions. In Java, an if basically is a statement, which is, it controls your flow. It's either one case or the other, but it doesn't return anything unless you use a ternary if. In Kotlin, an if expression can also be both. So let's say you have something like this. This would be very familiar if you use Java. It's just a check, and it returns something if it's true, and it returns something else if it's not. So this will work. But this is a very verbose way to do it. And actually, because this is an expression, our if expression will return the result. So we can say that our max will be the result of our if expression. And if we run this, oops, yeah, of course I have to return it. Return max, then it should work. So 27, but of course this is very redundant, so we can just return immediately, or even clean it up further and just say that this is A or else B, and then even we can use an expression block and make it really short like this. Oops, of course I missed one. And it works. So this is pretty tidy comparison to Java. You can also do it like this for readability. Okay. So it's a really good combination of the expression body and the being able to use if as an expression. Okay. Next big topic are nullable values. We've all been there in Java when you write code. Every day you encounter a null pointer somewhere in your error logs, or while coding something, you forget to initialize something, and you always end up with a null pointer exception. Also, when validating or checking something, you forget to check, and bang, there it is, null pointer exception. In Kotlin, this is no longer the case. Why? By default, everything is non-nullable. What do we mean by that? If we try to assign null to something that is of a type string, it won't allow it. The compiler will complain, because our type declares if it's possible for the type to be null or not. So if we add a question mark behind the type, it means that we have a nullable type. You can assign null to it, like this. If the question mark wouldn't be there, it wouldn't be possible to assign null, and we would get the compiler error. Then what happens if you have, let's say, a person that you get via a find person function, and a find person function might return a person, but also might return null. So then our person is of type nullable person, or person question mark. And also the compiler would complain, because it isn't sure if your person would be null or not. So this wouldn't even compile. Okay, nice, it's good, but how do we work around this? Because this is not really usable. We can check for it using a null check, or what we call a safe call operator. First one is just check if it's null. This is very familiar from Java. You just check if the person is null, and if not, then we can just execute it. Behind the scenes happens something called a smart cast. And this means that because you did a check for nullability, Kotlin automatically casts your nullable person to a person, because it knows that it can no longer be nullable. It can no longer be nullable. So, and you can immediately call the name you can get the name property on your person object. Then we also have a safe call operator, which in this case is person question mark. And if that's not null, you can get the name property. And if it would be null, then it would just return null. In this case, this is not really what we would like, because if our person doesn't have a name, or if person is not defined, we would print null. This is not good. This is why we have something called the null coalescent operator, which is a name which is horrible and nobody uses, so forget it. Instead, this resembles Elvis Presley. It's the Elvis operator. If you look at it from an angle, you can see that it's like his hairstyle and his eyes. So yeah, it's the Elvis operator. Think, okay, that's nice, but I kind of like my null pointer exceptions. I mean, it's kind of routine, it's second nature. Can't I just skip all that? I should have actually cut out this slide, but you can if you really want. And then in this case, you get our person, which can be null again, and you just tell Kotlin that you're pretty stupid, exclamation mark, which then tells Kotlin to back off, and you can call your .name, which can result in a null pointer exception. Please don't. Some people, yeah. Okay. Okay, type checks and automatic casts. We already touched this. We went from a nullable person, which was the person with a question mark, to a regular person, which is non-nullable. Sorry, not a regular person, a non-nullable person. In this case, we have a function that takes an object which is of type any. Any is like object in Java. So the root class, like the object class, is here called any. Just like unit in Kotlin stands for void in Java, any in Kotlin is object in Java. So you pass along any object and you check if it's a string by executing isString. Is the Kotlin version of instance of, so it's much shorter, yay. And if this is the case, then we can immediately call string functions on our object. So it's no longer of type any, it will be of type string without having to implicitly convert it or cast it, sorry. This will only work if your value, if it's a value, so if it's immutable. If it would be mutable, then smart casts will not happen because it might have changed, your object might have changed since you did the check. Okay, then we have for loops. For loops are basically the same thing as in Java, but a little bit more readable. You have, for instance, a list, which we will talk about a little later, a list of 3 cars, and then you can do a for each, but you don't have to define the type because you know the collection is of type string, generic type is string, so a car is always a string, and then you can just print everything. You can also get the indices from a collection and iterate over those, and then you can ask the element with that index, but this is kind of weird maybe and not what you really want. If you have a really big list, you have to do a lookup every time, and it's really efficient. So you can also do something else. It's called with index, which then will translate into something called destructuring, where you can have the index and the element, in this case a car, and then we can avoid this lookup and immediately print out our car. This might look familiar from other languages. Okay, so you see it still works. We print out the cars in the first loop, and then the index and the loop, and the item in the second loop. Okay. Then ranges, something, it's a nice feature in Kotlin, where you say you want to loop over something within a range 1.5. What do you think it would do? It will loop over 1 to 5, so it will print 1 to 5. But of course, sometimes you want to loop over something dot size or dot length, and you don't want to have the last item included. And instead of doing -1 at the end, like you would do in Java when looping over something, you can also use until. And until means don't include the last one, so you do 1, 2, 3, 4 instead of 1, 2, 3, 4, 5. You can also loop over things that are not numbers, like characters, everything that is iterable and that it can know what the next item will be. So in this case, you can also loop over A to D, which then prints this. Of course, sometimes you want to skip some of those numbers, and you can use something called progression, and then you can provide a step. So in this case, we print all the odd numbers from 1 to 10. This would include 10, but of course 10 is, it's 9 and then 11, so 10 is not printed. And then you can also go downwards with a different step. It could also be step 2, and then you have 9, 6, 3, 0. So it's pretty nice to generate ranges. While loop is actually not worth mentioning. It's the same thing as in Java. Also do while, which is not listed here. It's basically the same thing as in Java. Okay, then one expression, when, we don't have in Java, because when is basically a switch statement, but on steroids. In Java, I don't know if there are any fans of switch statements, but yeah, they're really horrible. You always forget to break, and then you go down to the next case, and it's horrible. In Kotlin, if you use a when, it's also an expression, so you don't have to return within your switch in Java then. You can just do a case, or what would be a case, and then return the value immediately. So it's an expression and not a statement. Let's say we pass along an object of type any, which is object, if you remember. We can check if it's 0 or 1, and then return a string 0 or 1. You can check if it is within a range, we just saw earlier, and then print something else. If it equals hello, you can do something else. And then also you can do a type check, so instance of is in Kotlin. We can do is person, and then it automatically applies what we saw before, a smart cast, and you can use the object as if it were a person, and you can call the name property. You can check if it's not an instance of a class. But the thing is, because it is an expression, you always need to return something from your expression. You can't just have no value that, if it wouldn't be, if this would be a string that is not hello, then what do you return? So you always need to provide a full, you need to have a result every time, so it needs to be exhaustive. So that's why usually you see an else case, which would be default in a switch in Java, and you need to return a value. So you can see that this is much more powerful already than a regular switch statement in Java. Okay, something more about collections, because we use those daily as well. Collections are basically based on the Java collections with some syntactic sugar. You can do a list of and provide some items, which will generate a non-modifiable list. So if you want to add an item, you need to generate a new list and assign a result to it. You can also make a mutable list if you want, by using mutable list of, which is all part of the core Kotlin libraries. And then you can add a new item instead of .add. Every time you have a collection in Java, you have to do .add and then add your item. Kotlin has operator overloading, so spoiler. So you can add items just using plus equals and add your element. Maps are also very easy to do. You can just simply do key to value and add it that way. So nice. And you also can get items from it the way you would with an array in Java. So you don't have to do .get to, but you can immediately provide square brackets. Like so. Okay, that about collections. Then of course, it's also an object-oriented language. So there is a lot to say about classes and creating instances. The thing is, for now, all our examples, I didn't use any modifier. So no visibility modifiers yet. And that's because in Kotlin, the default, in Java, what is the default modifier? Does anyone? Package private, indeed. It's the type, it's the modifier that shouldn't have existed in the first place. But okay, in Kotlin, the default is public. So if you don't provide anything, it's public. You can do this with class members. You see that the second column is a class member, so that means everything defined within a class. Top level declaration in Java would always be a class, but in Kotlin also functions can be defined on top level. So not even within a class, but even above or below it inside a file. Then we have internal, that's something new, Java doesn't have it. And internal basically means that something you define is only visible within a module. And a module is, for instance, a Gradle module. So you might have a web service module, and then everything you define there as being internal is only defined within that project. So that's good if you have multiple projects. You don't accidentally export something being public. It stays within that module. Then you also have protected, which is basically the correct way to do protected, because in Java, if something is protected, you can also access it from within the same package, which is sometimes used for dirty things, and to be able to access it. In Kotlin, if you define something protected, it's only visible within its own class and within child classes, so correct way. And you also have private, like we know in Java. Here it says also visible within a file, because if you define a top-level function, it's still visible for classes which are defined in the same file. Okay. Then constructors. This is what a class looks like. Looks pretty much like Java. You define a class, so this would be a public class. We don't define it. The default is public. We give it a name, which is person. And then here, that's something strange. This we don't have in Java. And that's because this is our constructor we declare for our class. So basically, if we want to make a new person, we have to provide a name. And then this is an initializer block. Every time you create a new object, This code will be executed, but it's actually pretty ugly, this piece of code, so you can clean it up and remove the initializer block, and you can immediately do something like this, which will then assign the name passed into our constructor to our property. This is still too much, because Kotlin can do it even better. We can get rid of the curly braces and just define our field like so. Because if you think about it, every time, or most of the times, when you create a constructor, you pass along some arguments, and then you just basically do this dot field equals argument field. It's always the same thing. This dot something equals something. And Kotlin is based on years and years and years of enterprise experience. And so they thought, like, this is not the way to do it. It's always the same thing, always the same ceremony. And this is basically why they came up with this way of defining and initializing your fields. Wait, oops. Okay, how do you create an instance? In Java, it's new class name and provide arguments for your constructor. In Kotlin, it's almost the same thing, but the new keyword is gone. So you can just create a person using person and provide your arguments. So more concise way, this is basically a recap of what I just showed. So if you provide val or var, it creates an immutable or mutable property. If it's a val, then it will also generate a getter behind the scenes. Now, in Kotlin, you don't do get or set. You just call, every time we use the person example, we always did dot name, and behind the scenes it would call a getter, but you don't type get name or set name. So you just always do the field name. But if you define something as a val, you create behind the scenes a getter and a field for it. If you create a var, what will be generated extra, you think? A setter, of course. Okay. Of course, sometimes we want multiple constructors. One is not enough. Then how do we do it? We define our primary constructor, like we just mentioned, and then we can use a constructor to provide a secondary constructor. So in this case, it takes 2 arguments and then calls the primary constructor. Normally, in your secondary constructor, you would call in Java, you would start your method block and then type this something if you want to call another constructor with some predefined value or something. Here you can do colon and then immediately call this. You could still do a method block after this, but this is not necessary. Yeah, so and then you can create a new object to show what this does. So you provide Yannick and Mr. as a name and title, and then if you would print his name, because the primary constructor would take the arguments in the other way around, it would print Mr. Yannick. Okay. You also have properties without a backing field. A backing field is a location for your variable to be stored. You can define an immutable variable, let's say upper name, but we don't actually have to store this because it's redundant. We can calculate it from our name. Our constructor takes a name, so the upper name is just our name into uppercase. We can store it as a value, but without storing the actual value. So every time you call this, the getter gets called. You can do it this way, and you can override your getter. And in this case, every time you call dot upper name on an object, this will execute, and it will just take your name, which has a backing field, and execute the toUpperCase function on it. Then you have accessing the fields inside. So you have getters and setters, which can be changed. This is what it would look like. So you can change your getter and setter. This is pretty redundant. You could get rid of this because this is the default implementation, but it shows that the value of your property is stored within field. And then if you set something, you pass along an argument and you change the field value to the new value you provided. So if we then create a person, me, named Jeroen, and we print my name, should still print Jeroen, but then we can do stuff like print a change. of the old value to the new value and make it clear that what change just happened. So let's say print changing from, and then this should be string interpolation. Here it's still the old value, field 2, it's difficult typing behind your back, 2, and then it's value, because value is our new value. If you print it like this, you can see it's changing from unknown to Jeroen, because initially I didn't specify any name, so it defaults to unknown, which is the default value. Okay, default value, this is something we don't have in Java, alas. In Kotlin we do have it, so let's say we have a primary constructor for our person class, again the person class, I know, sorry. You can say that first name, this is basically like we did before, there's a last name, shocker, and then you can say that the first name is equal to foo. This means that the default value for a first name is foo, so if you don't provide any first name, it will just take this value. You can already see that this is pretty nice for method overloading, that you don't need to do it as much anymore. So let's say you create a new person, you can say that you can name your arguments. So if you would just provide snow without providing a second argument, normally this would reflect the first name value. But now you state that you want the last name to be snow, and then it would print foo snow if you have the full name. Also note that if you would use this and you would use default values, always provide values that have no defaults as first arguments, and then the ones that do have a default value. Okay. So actually this example was bad, but yeah, my mistake. Then operator overloading, this is something we already briefly mentioned. Oh, yeah, sorry, I can't see it on my screen. Okay, operator overloading, it's nice. Basically what it does is you can define operators not only for primitive types, but you can define them also for objects. So let's say we have a number class and it just takes one value, which is the number. Then we can add objects to each other, which is nice. Normally in Java you would do, if you would want to add number 1 to number 1 to number 1, you would do number 1 dot add number 1, and then the result of that should add again number 1. But here we can just use the plus operator because we define it. How do we do it? We just say operator fun, because it's very fun to do, and then plus. Those are predefined words. It's plus. You can also do multiply and yeah, a long list of others. Minus is also possible. And then you just define what it should do. So in this case, it takes another number, because if you look at this operation, this is what we are defining. It's some number, and then you give it another number, and then you define what the end result should be. So it should create a new number with the sum of both numbers. So if I have a number here that is 2, and I add it to itself 2 times, this should give 6 if everything works. Yeah, and it does. So this is a really nice syntactic sugar, yeah, if you're programming. Oh yeah, also, if you note, for collections earlier, you could do your collection plus equals, so the shorthand notation, you could just add it that way. This is also done via operator overloading. Okay, extension functions. How many times have you encountered something where you have a class and you wish that a certain method was available? How many projects have you had that didn't have a string util class? If you don't have a string util class in your project is not old enough yet. Probably. This is why Kotlin invented the concepts, or uses the concept of extension functions, which basically adds new functionality to an existing class without having to modify that class. Sounds weird? Let's check it out. Okay, so let's say we have a person class again. Then we want to be able to do something like upper name, but we won't touch the person class because upper name might not be convenient for others to use. It might be really specific for your use case, but you don't want to add it to the person class. Or the person class is just some library. It's from a library that you've imported, and you can't, you can't extend it. Yeah, you can extend it maybe, but you don't want to do this. So how do we do it? We just declare that we want to add the upper name function. So it's fun, of course. Then person, so the name of the class that we want to extend the function onto, and then the name of our function. So in this case, it's upper name. And then again, we tell it what to do. So now we need to get the name property of our person. Luckily, if you do it, if you define an extension function, this, in this case, will refer to the person and no longer to the class or the place that you are working in. So if we do name, there, it gets auto completed. We can do to uppercase, and now it should work. Mind you that I'm not tricking you. If this would be done without defining this, it would obviously give a compiler error because upper name is not defined. So this is a really cool way to extend and to add functionality to your classes without altering them. Also, if you define extension functions, you can use these from another package or another file, and you can actually import them. So if this would be my package foo, I can go to some other place and just import foo.uppername, and then this method is available on the person class. This is also why Kotlin has a very rich string class by design. You can check if something is blank or empty or not blank or not. So a whole lot of methods just because you're able to extend existing classes. So yeah, they're resolved statically, and you can also do it for properties. And properties are also available. This is what I showed using this because it refers to the person object or the class that you are extending. Okay, then one of the last things, because I know it's a lot of theory, I know, sorry. INFIX notation, this is pretty cool. You might have seen this before. It's syntactic sugar, and it's especially useful when you're working on DSLs. And basically what it is let's say we have our person class again, because we love it so much. If you have two people, you can normally, if you would call a function, if you write a function, brofists some other person, then you would write it this way. And if you execute it, you get the result that would be expected. But of course, the infix word is here, and what does it do? It makes it so that you can call it this way, infix way, and it still works. The only limitation to this is that you can only provide one argument, but it's really nice and it's very readable because this is actually just English language. Okay. Okay. If you heard about Kotlin, chances are you've heard about data classes. Data classes are the solution to DTOs and all the lengthy discussions we had about using Lombok or not using Lombok, and then earthquakes. And yeah, so basically Kotlin solves this problem for you very elegantly without using a load of annotations and forgetting to enable compiler annotation processing. So what do? You just have a regular class, again our person class, because by now it should be patented or something. And then we just add the data keyword in front of it, which makes it a data class. On the first, if you look at it, it doesn't seems to have changed. You instantiate it just like you would a regular class object. But behind the scenes, some interesting stuff happens. Namely, it's made to hold data, but the compiler does a lot for you. It generates equals and hash code because it's a DTO, which means that the unique set of arguments you provide for it will define if it's the same as another object if they have the same values, then they are equal. So Kotlin will generate, based on these principles, will generate an equals and a hash code for you. Also with toString, so if you print something out, it won't just show your memory address. It will print something like this, in case of our person class. And it also provides destructuring support. Okay. And also a copy. The copy is to be taken with a little bit of caution, because the copy is actually a shallow clone that it takes. So it's not always that great. But if you use primitive types only, then it's nice. And behind the scenes, what actually happens is it just creates a new instance using the values of the old data class object. So if the original is Yannick de Turk, then the copycat in this case would be me, and then would be Jeroen de Turk, because I forgot to change the last name. Story of my life. Okay. Then we get back to destructuring. I already mentioned destructuring a few times. What does it do? Let's say we have our person class again. It's a data class this time. And we create me, which is a person. I'm 16 years old. Typo. No. Okay, then we can destructure it. Destructuring is like this. We saw it before with when we did the for loop over the cars. You would have a combination of the index and the car object. That was also destructuring. Here we do it with name, and then we could also provide the age, so my age or whatever. But in this case, I don't need the age, so I can replace it with an underscore. But basically, because I don't need it and it's the last part of my destructured object, I can just get rid of it. So this would work, and this would get the name from my object, assign it to its own value, namely my name, and then print it. If you would like to print my name in this case, then we weren't interested in the name, but then we get the age from it and then print my age. Plus 13, no, plus 12, yeah, whatever. And then it's 28, okay. So this is a very nice feature, but obviously just for data classes, you might think, yeah, but what's the big deal? Why not just use your object and do .name or .age? It's not that much. Well, sometimes you have a function that you want to return, and you want to return multiple things, but then you end up using some kind of pair, or you define an object with multiple fields that you can return to have all those multiple values. This is where it's really handy. You return this object, in this case DTO, a data class, and you can immediately destructure it, and you have all the parts of the things you wanted to return. So maybe an error list and your result set or something, you can immediately return them. So it's very useful with function results. Obviously, this destructuring support, I told you that it's Kotlin does this and adds this support for data classes. So what would happen if we remove the data from the data class? It becomes a regular class. And if we destructure it now, it says, and it complains, because it doesn't know how to destructure your object. And this makes sense, because if you have a data class, every field or every property inside is something we want to use. It's data that we use. But if you have a regular object, then there might be some internal stuff that you don't want to expose. Maybe you do, but Kotlin doesn't know. And it basically gives you the option to define destructuring support. So you can do this very easily. I'll show you. It complains that it can't find component 1. Component 1 is the first component of your destructured object. So we could use operator overloading that we saw before. Operator fun, and then we define this. Oh crap, okay. Component 1, I accidentally copied something else. And then we tell it, what do we want to do? What do we want to give back as the first destructured argument? Well, it was our name. And the second one, so you can do this for every thing you want to give back in your destructured object. And then we say it's age, and then this should work again. And it's working. You could also alter the sequence here, but yeah. So like I said, it's very useful if you have a function that wants to return multiple things. Okay, so you could do it with just a regular pair, like you would in Java, but then destructure it instead of .get left and get right, which doesn't always make sense. And you can use it to print something. Obviously, val1 and val2 are not really good names. You should give them something a little bit more precise, like errors or result list or whatever it is returning. And it's also useful for maps. We use it for a collection with the index and the object, but you can also use it for the key and value for a map and then iterate over it. Okay. Then one thing that is really important to mention, and I'm almost done, sorry, it's taking so long. By default, everything is final in Kotlin. In Java, everything by default is open, and only when we define something as being final, it cannot be overwritten in a subclass. And you specifically have to provide open to tell Kotlin that you want your class or your method to be overwritten. This is because by default, if you're not thinking about it, you should really consider if your function should be able to be overwritten, because otherwise if you don't and people try to mess with it and they think like, oh, I'm going to change this and I'm going to change that, it's something you as a developer of the original class didn't anticipate to, and it creates brittle code, and it's not a good thing to do. You should be in charge of telling people who use your code what should be overwritten and what is like it is. So let's say we have an animal class, it's open class, so the open keyword gets added, and you define a function run and a function make sound. The make sound function can in this case be overwritten because it's defined as being an open function, and run cannot be overwritten. Although our class was defined as being open, our run function cannot be overwritten because it's not marked as being open. So this open will only point out that the class can be subclassed. So if you have a cat, then you can extend animal, extend this colon, and then our animal. This points out that if you instantiate a cat, normally you have to call a super. You have to call the constructor of the super class. In this case, you can do it this way. So it immediately tells use the default constructor over animal, and then you override the make sound function, and you have to provide override. If you don't put override here, the compiler will complain. In Java, we don't have this. You put an add override annotation, and if you don't, then it's perfectly happy. But in Kotlin, you really have to specify it, and this is done so you don't accidentally override a function. I don't know if this has happened to you, that you define a function not knowing any better, and then suddenly something doesn't work anymore because apparently you overrode something from a superclass. Okay. And then also, if your superclass has a property, name in this case, and you want to have a subclass, the same thing happens. You provide, you have an argument in your constructor of cat, namely name. This calls the constructor in the superclass. It passes through the name argument. And you can also create a secondary constructor, then call the primary constructor, and the primary constructor will call the animal constructor with name. So this is how the super calls of classes are handled. Okay, really there. Okay, one last interesting thing is, I told you before, if you use a when statement, every case needs to be handled. If there is something that is not handled, then there is no result for your expression, and this is simply not acceptable because you need to have a result. In this case, we have an expression and we have some num and sum, and basically what you can make is an expression. Everything is either a sum, so then it has a left-hand side and a right-hand side, and it's either a number or another sum. And then in the end, you all have numbers that you can, you have some kind of tree structure, and you can, in this case, count them all. So sum is basically the sum of the left and the right-hand part, and a number is just a value. If you would use a when statement here to evaluate your expression, then you would have to throw in an else clause, because the compiler is not sure that num and sum are the only subclasses of your expression. And by the way, in this case, I didn't even mark my expression superclass as being abstract, so I can even instantiate it, and this would already break my when structure if the else would not be present, because then I have no class for my num, for my expression, because I only handle the cases num and sum. So this is not really elegant because sometimes you know that these are the only two subclasses of expression. So we would actually like to do this. But if you run it, of course, Kotlin complains and it says, hey, it needs to be exhaustive. This we can solve not by making it abstract. We could make it abstract. Note also that the open keyword is no longer needed here because abstract implies that it needs to be subclassed. What we can do is, if you read on the top, is use a sealed modifier, and sealed means every subclass of this class will be within this file. It used to be within this class, that's why the sealed name was so nice, but they relaxed it in Kotlin 1.1, and now you just have to define all the subclasses within the same file. So this means that it will only look in this file for childs, and now it sees like, okay, only num and sum are candidates. So if you run this again, it will no longer complain. And even if we add an else clause again, Kotlin will help you. We will give back 2 or something. Come on, internet. We see Kotlin, the compiler says 1 is exhaustive, so else clause is redundant. So it knows that you no longer need the else clause. Of course, if you would add a type, a subclass here, Kotlin would complain again because you didn't handle all the types, but now it knows. So this is a really cool feature to make everything more concise. And also points out again that you need to have, if you use an expression, you need to have a return, you have to have a result for your expression every time. So then you can restrict your class hierarchy, and it must be within the same file. Okay, then we still have object. I'm going to fly through. Object is basically the solution for a singleton, which we always have to look up to make sure it's synchronized and it's safe and everything. Here you just say object, which just basically means you define a class and you want to create one instance of it. So in this case, you have just one object of my singleton. You also have companion object for use inside a class. And you can extend classes and interfaces from it. And this is mostly used for factories, like so. And then you can call it just class create. Okay. And then we have tuples and pairs as well. But these are actually not really necessary because you have data classes which are so easy to create that it's basically no longer needed to use pairs and triples to return multiple values from your functions. But you could use them. Okay. Interfaces, almost through, I guarantee you. Interface, yeah. You have, we had open classes and abstract classes, and you also have interfaces. Interfaces are very familiar. They look a lot like the interfaces in Java, but then with the Kotlin syntax. So you can define functions. By default, they are open. You don't have to provide the open modifier because interfaces need to be implemented, so you need to implement the methods. How do you implement it? Same way, you no longer have extends or implements. Everything is colon and then comma separated. You can only extend one class, but you can implement multiple interfaces, again, as in Java. And then you just override. You have to provide the override modifier keyword to indicate that you're overwriting a function from an interface as well. Okay, then you also have properties. I'm going to skip this one. Enums are pretty much the same thing, but you declare them enum class. And that's it. Okay, still awake? I'm sorry, it's a bit dull, I know. But, how do you get started? Well, setting up is easy. If you use IntelliJ, of course, Kotlin being developed and actively maintained by JetBrains. IntelliJ is out-of-the-box support. It has a Kotlin plugin and also a special plugin to handle Java to Kotlin conversion, which is nice to play with. Doesn't always give you the best or most readable code, but it does a great effort. You can also copy Java code and just paste it in a Kotlin project, and it will automatically do the conversion for you. Eclipse also has a Kotlin plugin, and there is also really great support for Android Studio. And you can install it if you use a MacBook, because I see most of you use MacBooks, by just using brew. Okay, so was a lot of nice features, a lot of things that the longer you use Kotlin, the more you realize this is the situation. Java has been around for like 30 years, and they want to get modern features in their language, but it's not as easy because they try to, they are so stuck on their backwards compatibility that, sometimes it feels like you're pushing a lawnmower and then you get grass in your face while you could be sitting on an automated machine that is Kotlin. So, some more information on most loved features. It's the null safety because it's so nice. It's easy to check for, if you have a nullable type, remember with the question mark, it's really easy to check if something is null or not. Also the extension functions, you forgot something is not present, just write an extension function for it. And also the interoperability, everything you ever wrote in Java is still there. You don't have to write everything from scratch as if you would use a totally different language. And data classes, because DTOs and all their hassle are a thing of the past, just as is Lombok. Yes. Okay, some references where you can find tutorials and documentations. And then the talk is over. The theory part is done. We'll just cool down first with a few quiz questions. Oh, sorry. Question 1. We have this piece of code. What if I run this piece of code? What would the result be? I give you a little time to think about it. Have an idea? Okay, anyone wants to give it a try? I hear compilation error. Okay, who says A? A, okay, nice, very brave. Who says B? Okay. Who says this is going to be definitely a trick question? I hate you already. Of course it was. Okay, in Java, if you have an int and a long, those can be boxed into each other and they can be auto-casted. In Kotlin, this is no longer the case. An int is an int, a long is a long. If you want to do something like this, you would have to use the toInt function, I think. Oops, it's with a capital I. And then, still a compilation error, and then you can laugh at me again. No, so this works. Okay, so it was compilation error, so Chris was actually correct. Great job. More type safety, yes, indeed. Thank you, Peter. By the way, have you ever wrote tests? This happens so often. You write this kind of test, and then you assert that your ID or something is equal to, and then you type your ID again, and it says, 1024 is not equal to 1024L. Those kind of problems, yeah, we've all been there. Just use type safety. Always use the same types, and don't imply that everything will be automatically boxed into each other or cast from one type to the other. So I know it was a bit of a trick question, but I promise you there is a second question that will definitely not be a trick question. Okay. So we have two strings, one lowercase, one uppercase. Then we do a check if string 1 is equal to string 2.lowercase. Okay, place your bets. Anyone wants to make a guess? Anyone wants to make a guess? Already, okay, I'm actually dying on the inside now. It's yeah. Anyone? A? B? Who has no arms? Okay, we'll see. It actually prints A. Why is this? Every time in Java, when you compare two strings, every so often you get like a brain and you type equals equals instead of dot equals. So you use the equals sign. This only works for primitive types and not for objects, because in Java, if you use this kind of comparison, it will check the object reference, and for two different objects, it will return some other value, and it won't be equal. In Kotlin, this is the case. This is actually also done via operator overloading, correct, on any, and then you can say that equals matches this way of declaring things. If you do like the Java way, you can still do it by adding an extra equals sign, and then it will check the reference as well, and then it should be P. The thing, if I would also do, and I only discovered this too late, if you do hello like this, and you remove the to uppercase, this will also work, but this is because of optimization. The two hellos that you create will actually be shared. So it's actually the same memory reference, and then the party trick doesn't really work. So, yeah, sorry. Okay, last question. We have a enum class with the 4 seasons, and then we have a function love-hate where we pass on a season, and then we use with the expression body, remember with the equal sign, we use an expression body, a when statement. Remember from a few slides ago, if you had 0, 1, it would return 0 or 1. So the comma means that it's either one of the items you provide. What would the answer of this piece of code be? Null pointer exception. Okay. What, Ken? Okay, so the question is it exhaustive? It's a really great question. That's actually what I wanted you to think about. What do you think? Do we need to provide it, or is it complete? It's complete. So we love it. Nice. Great. So not everything is a trick question. And now I'm finally through with the theory part. Okay, so any questions?
What's the long-term support for Kotlin like? Will it exist in 10 years? Or will it,
It's a very good question. The question was, will Kotlin still exist? What about its support, and will it still exist in 10 years? Well, that's obviously a great question. And the thing I hear people say is, but won't Java achieve this kind of syntax? But this is simply not the case. And because Kotlin compiles to JVM bytecode as well, I don't see any problems for it towards the future. The thing is also, Kotlin was designed in the beginning of the presentation. I pull in the history again. It's developed since 2010, and then it was released somewhere around 2016 or 17, I think. It was aimed towards Java 6, which means if you generate the bytecode, it's aimed towards JDK 6, which means for some things, like if you create an interface, I went over it very fast, but if you create an interface, you can also provide a default implementation for a method. So functional interfaces, we have this in Java 8. You can provide already the body of your method, but if it gets compiled, because it's targeted to Java 6, the implementation will be gone. So if you call an interface with an implemented method from within Java, then you have to implement it again because its implementation is gone. These are things that are kind of, for me it's only an issue when you work with Java and Kotlin together, but I think using them together is only for a phase of our existing projects. So I won't bet my life on it, but
some people have to bet the company on it.
yeah, some people have to bet the company, that's true. If all people are very skeptical towards it, then obviously, go back to Java and good luck with Lombok. But for me, I'm more than happy to give it a try. At least what you can do, for instance, because it's only, if you want to use it, it's only one dependency you have to add to your POM or to your Gradle script, is you can write your tests using Kotlin, or you can just use for your DTOs, you can use Kotlin. Then if there's no longer support for Kotlin, you can still remove them and generate all getters and setters again, because you're not going back to Lombok afterwards, I can guarantee you. But at least then you can have the best of both worlds without having to fear that everything you ever wrote in Kotlin is going down. So, it's a valid question. Any other questions?
What about frameworks like Spring?
Well, that's a really good question. The question is, what about support for frameworks like Spring? Actually, since Spring 5, there is excellent support for Kotlin, and actually they also use Kotlin to make their APIs more concise. But if you're interested in that, I would suggest you come back next week, because then we have a hands-on session about using Spring and Kotlin. This was not a prepared question, by the way. It really wasn't. Yeah, great question. So you can, even if companies like Pivotal with their Spring, if they go on board with Kotlin, then you can assume that it's here to stay, because yeah, can you still imagine Java without Spring? For me, it's actually pretty hard as a backend developer. So, good question. So come and find out next week. Yes, Yannick. Okay, so the question is, what about testing and mocking in Kotlin? I haven't looked into that. For the exercises, there are some tests written, and you can also see some nice features in Kotlin towards naming, but I haven't used any frameworks. I use very basic assertions. I haven't done any mocking, so no. Yes. So yeah, the question is, if you want to use anything like a mocking framework, then because Kotlin by default is everything is closed, and you have to specifically define it as being open, it's very hard to wrap it in a proxy or use CGI lib or those tools. How do you work around it? That's a great question, and I can't give you an answer to that. Okay. Okay. I would like to hear all about it during the break. Great. Thanks.